Hi folks, we're going to take a look here at Unit 6, Quiz 2, and we're going to start with number 1. So they're asking us to determine the axis of symmetry of this function in two different ways. So recall that the axis of symmetry is given by the x value of the vertex. So since it's coming from the vertex, one of our options is to complete the square. Okay, so let's start that as option 1. So in order to complete the square, now I'm going to show all the steps here. There may be a couple that you might want to skip along the way. But first thing you have to do is always factor out the coefficient of x squared from the first two terms. Okay, so I'm factoring out the 4, and here I'm left with x squared minus 6x. Okay, and then the plus 27 we can leave till the end. Okay, and the idea here is to get this expression in a particular format. Okay, and the format we need is x squared minus, because it's a subtraction here. Okay, and we need to write this as 2 times what's going to become our h value. Okay, x. And then in order to be able to get our perfect square for vertex form, we need to add 3 squared, h squared. Now in order not to change the value, we also subtract the 3 squared. Okay, and then we still have the plus 27. Now, I'd just like to say here that this number inside the bracket is automatically our h value. So we could really just stop here and say that the axis of symmetry is x is equal to 3. But since we're doing this, we'll continue on and complete the square fully. Okay, so here, the first 3 terms. So the reason why we wrote it this way is because something of this form factors perfectly to x minus our h value squared. Okay, but we still have this minus 3 squared tagging along, so minus 9 and plus 27. Okay, and now in order to clean this up, we first distribute the 4 to both terms in the bracket. So here we're left with 4 times x minus 3 squared. So this is going to be negative 36. And now finally we'll incorporate the plus 27. Okay, so in the end we have 4 times x minus 3 squared, and negative 36 plus 27 is negative 9. Okay, so this is in vertex form. In other words, the vertex is 3, negative 9, but all we want is the h value, because that's going to give us the axis of symmetry. So since h is equal to 3, the axis of symmetry is x equal to 3. And it needs to be given in equation form because this represents a line. Okay, in this case here, a vertical line. Okay, so let's now move on to another possibility. Okay, and this is again understanding how we can use the different forms of the equation to get the information that we want. Okay, another way to get the value for the axis of symmetry is to find the average of the x-intercepts. So if we can find the x-intercepts easily, we can just average them, and that'll give us the axis of symmetry. Okay, so I'm going to try to find the x-intercepts by factoring here. Okay, so again, always look for common factors. In this case, there are none. Okay, so I want to try to factor this into 2 binomials, but because I have a coefficient in front of x squared, it's, might take a little bit of time. Okay, so again, I'm going to use trial and error. So for 27, okay, remember what we do. Our factors of 27 go in these positions, and I'm going to represent them in my second column. So I'll start with 3 and 9, and then in my first positions are going to be the factors of 4, which I'm going to represent. I'll start with 2 and 2, see if that works. Okay, so now it's a matter of testing all possible combinations to give us our middle term. So we can either do 2 times 3, 6, and 18, and lo and behold, right on our first shot, we end up getting exactly something that works, because 6 and 18, okay, or negative 6 and negative 18 will add up to negative 24. Okay, so this is going to be 2x, 2x, and here we can make this one 9 and this one 3. Okay, and since we have to add up to negative 24, it's going to be negative 18 minus 6. Okay, now remember that this is not in what I call official factored form. Okay, in order to do that, I'd have to factor out the 2 from the first expression and the 2 from the second expression. But remember, I don't actually need to do that if I'm just looking for the x-intercepts, because remember that To find the x-intercepts, I set y equals 0. So I'm essentially solving this equation here. Okay? And this can be solved quite easily because we know that one of these two terms has to be 0. So either 2x minus 3 equals 0 or 2x minus 9 equals 0. So let's solve these. This gives me, bring the 3 to the other side, divide by 2, so 3 over 2, or x is equal to 9 over 2. So these are my x-intercepts. If I want to locate where the axis of symmetry is, I just need to average these out. Okay? So the x value of the vertex, or my h value, if I want to use that terminology, is just the average of these two numbers. So 3 over 2 plus 9 over 2 divided by 2. So this is 3 plus 9, 12 over 2 is 6. And so here we go. So our axis of symmetry is, as we found before, x equals 3. Okay, so important thing to keep in mind is how we can find the vertex using completing the square if we have standard form. But if I already have it in factored form, it might be just easier to find the zeros and average them out to get the x value of the vertex. And if I did need the y value of the vertex, I would just take this number, plug it back into the equation. Okay, we'll stop there for now.